Hello everyone, welcome back to my presentation. My name is Ruchi HP. I am the student of Sri Venkateshwara College of Engineering, Bangalore, from the Department of Computer Science and Engineering. And today's subject is Mathematics for Computer Science. And today's topic is ANOVA, Analysis of Variance. Contents: Introduction to ANOVA, Principles of ANOVA, One-Wave ANOVA, One-Wave ANOVA Example, Two-Wave ANOVA, Two-Wave ANOVA Example, Assumption of ANOVA, Limitations of ANOVA, Conclusion. Introduction to ANOVA. Analysis of variance is a statistical technique used to compare means of two or more groups. It helps determine if there are statistically significant difference between the means of the groups. ANOVA is based on the assumption that the observations are independent and come from normally distributed population with equal variance. Principles of ANOVA. ANOVA partition the total variation in the data into different sources between group variations within group variation. It calculates an F statistics by comparing the ratio between group variation to within group variation. The F static is used to determine whether the group means are significantly different. One-wave ANOVA. One-wave ANOVA is used when there is only one independent variable or factor. It compares that means of three or more groups to determine if there is statistically significant difference. The null hypothesis in one-wave ANOVA states that all group means are equal. One-wave ANOVA example. An example of one-wave ANOVA is comparing the average test score of students in three different testing methods. The one-wave ANOVA test will determine if there is a significant difference in test scores between the three teaching methods. The output of one-wave ANOVA includes the F statistics, p-value, and the conclusion about the group means. Two-wave ANOVA. Two-wave ANOVA is used when there are two independent variables or factors. It examines the interaction effects between the two factors in addition to their main effects. Two-wave ANOVA can help determine if there is a significant interaction between the two factors on the dependent variable. Two-wave ANOVA example. An example of a two-wave ANOVA is studying the effect of both diet and exercise on weight losing. The two-wave ANOVA test will analyze the main effects of diet and exercise as well as the interaction effects between them. The rest of two-wave ANOVA can provide valuable insights into the combined effect of multiple factors on the outcome. Assumption of ANOVA. The assumption of ANOVA includes normality, homogeneity of variance, and independence of observation. Normality consumption requires that the residual follows a normal distribution. Homogeneity of variance assumption states that the variance of the groups are equal. ANOVA assumption An ANOVA is a parametric test. That means there are some criteria our data must meet. If you want to use it, the data should be normally distributed. The data should be independently sampled. If we have independent group of 5, there must be a homogeneity of variance. If we have to repeated means of having a sparsity. Limitations of ANOVA. ANOVA assumes that the data meet the underlying assumptions, which may not always be the case. ANOVA does not provide information about the direction or the strength of the relationship between the variables. ANOVA is a sensitive to outer lineup and may not be robust in the presence of extreme values. Conclusion. ANOVA is a powerful statistical tool for comparing means of multiple groups and analyzing the effect of multiple factors. Understanding the principle of ANOVA, including one-wave and two-wave design, is essential for conducting meaningful statistical analysis. By following the assumptions and the best practices of ANOVA, researchers can draw valid conclusions from their data and make informed decisions based on statistical evidences. Thank you.